All right, this is the second exercise from the tutorial. So I want us to solve this differential equation using the variation of parameter as we did in the previous one, okay? So you are given this second order differential equation. Of course, cosec x here is just 1 over sine x. As we did in the previous exercise, let's start with the homogeneous equation. The homogeneous equation is d plus 1 y of x is equal 0. Remember, as I say, y, this is y prime prime plus y equal 0, okay? So the auxiliary polynomial p lambda is lambda square plus 1 equals 0. This means lambda is plus minus I, right? This is what we obtain for the characteristic equation. The solution is y1 is equal cos x and y2 is equal sine x. So the solution to the homogeneous equation is a cos x plus b sine x, with a and b in R. All right, this is what we obtain. At this stage, we want to look for the particular solution, given that the total solution is the sum of the homogeneous solution and the particular solution. So to find the particular solution using the variations of parameter, we have the following: u prime 1 y1 plus u prime 2 y2 is equal 0. And the second equation is u prime 1 y prime 1 plus u prime 2 y prime 2 is equal, the left hand side of this is c cosec of x. All right, if you want to write this as a metric, so this is u1 is cos, so this is cos x. The derivative of cos x is minus sine x. u2 is sine x. The derivative of sine x is cos x. All these multiply u prime 1 and u prime 2. This is equal 0 and cosec of x. All right, at this stage, if I call this matrix, this is the matrix M, okay? So it's just M times this vector u is equal the right hand side. So basically, to solve this, we can just use the inverse. We multiply this by the inverse of the matrix, and we obtain u prime 1, u prime 2 is the inverse. This is m minus 1 times 0 cosec of x. So how do we obtain the inverse here? Remember that if you are given the matrix M is equal A, B, C, D, then the inverse of this matrix is just 1 over the determinant of M multiplied by this D A. This is minus B and minus C. Okay, if then we apply this formula here, we obtain the determinant of this matrix is 1, so this is 1 over 1. We multiply by the inverse, this is still cos x, this is minus sine x, this is sine x, and this one is cos x. We multiply this by 0 cosec of x. So if you multiply this matrix, you have minus 1, because this is 1. Remember that this is cosec is just 1 over sine x, okay? So this is 1 minus 1, and this one is cos x divided by sine x. All right, at this stage, this is u1 prime and this is u2 prime. We can expand this. u1 will be minus x plus a constant c. So for the second, u2 is this integral of cos x over sine x dx. And I think this is the logarithm of sine x plus a constant d. All right, now that you have u1 and u2, you can write yp, the particular solution is just u1 times y1. So this is minus x plus c times y1 cos x plus logarithm of sine x plus d times sine x. For the total solution, it is the sum of these two. If I expand this, this is minus x cos x plus c cos x plus sine x logarithm multiplied by the logarithm of sine x plus d sine x plus a cos x plus b sine x plus a cos x plus b sine x. All right, at this stage, if we start with this constant, if we start with distance, we have y equal minus x cos x. I start with this. After this, I also take this term. This is sine x log times logarithm of sine x, and we have cos x here and cos x, so this is a, this one, okay, we take this term and this term together. This is a plus b times cos x, and the last one is just this and this. So let's write this. This is b plus d sine x. Okay, I just factorize common terms here, and if we call this guy alpha, let's call this one alpha, and we call this beta, then the final solution is this: y equal minus x cos x plus sine x times logarithm of sine x plus alpha cos x plus beta sine x. So this is the final solution. So this is the solution to this differential equation. So as you can see here, we just use a normal procedure. So here I use the inverse of the matrix. Okay, I call this matrix M, and I use the inverse of the matrix. So in the third example, I will not use this inverse anymore. So follow me in the third example to see all the possibilities that you can do when you are solving the non-homogeneous differential equation. Okay, cool, thank you. See you in the next video.